Okay, so let's look at what to do when we find a geometric series. So we have the summation from n equals 1 to infinity of 25 times 4 fifths to the n power. So we needed to verify that this is a geometric sequence. I have 25, which is going to be my a value. It's the thing that's being multiplied. And we have some number raised to a power. This is going to be r. So this is in that form of a geometric sequence. So now we need to decide, does this converge or diverge? So we're going to say this is geometric. R is equal to 4 fifths. So the absolute value of r is equal to 4 fifths. This is less than 1, so our series converges. So now we are going to decide what it converges to. So we have our sum is equal to our first term divided by 1 minus r. Well, we already decided r is 4 fifths, so we're going to have 1 minus 4 fifths. And our first term is when we plug in whatever is equal to n into our function. So we have 25 times 4 fifths to the first power. We figured out what that was just a little while ago. This is 20 divided by 1 minus 4 fifths is 1 fifth. So we have 20 divided by 1 fifth, or 20 times 5 over 1, which equals 100. So the sum of 25 times 4 fifths to the n power starting at 1 is going to equal 100. This makes sense because as we kept adding on terms, we are getting closer to 100, and we just would have never passed 100. Okay, we're going to look at the same thing, but with a different starting value. So, same things. If we want to know if it's converging or diverging, the first thing we decide is what kind of sequence we have. Right now, we only really know of geometric, so we would look for geometric first. This has an r value of 4 fifths, so we're looking at the absolute value of r, which is 4 fifths. This is less than 1, so this converges. So now we find our sum. So our sum in this case, we're looking at our first term divided by 1 minus r, that 1 minus 4 fifths. This time, our first term is when we plug in 0. So we're plugging in that value of 0 first to help us out here. So 25 times 4 over 5 to the 0 power. Well, 4 fifths to the 0 is 1. 1 times 25 is 25, so I have 25 divided by 1 minus 4 fifths, which is 1 fifth. So we are going to do 25 divided by 1 fifth, which is the same thing as 25 times 5. This is equal to 125. And that would make sense because it's 25 more. It's adding that one extra term to the one we just found. And then the same thing here. We already know this is going to converge because it's the exact same function. We're just starting at 4 this time. So this is geometric. The absolute value of r is equal to 4 fifths, less than 1, so it converges. So now we're going to find it. We still have 1 minus 4 fifths in the denominator. Our first term, we're plugging in 4 this time, so we have 25 times 4 fifths to the 4th power. If we figure out what that is, that happens to be 10.24 divided by 1 fifth. And if I figure out 10.24 times 5, because it's the same thing as dividing by 1 fifth, that's going to equal 51.2. So when we're doing this, the biggest thing here is identifying what our sequence or series is, and deciding if it converges or diverges, and then we can make some decisions from there. The sum of that last one is starting at that 4th term. So when we're looking at this last one, it's taking everything from the 4th term and adding everything on after that. So it's just taking off those couple of terms before. The big difference between what we just did and the fourth partial sum is if I were to do the fourth partial sum, fourth partial sum would be adding a1, a2, a3, and a4 together. So this would be the fourth partial sum. The sum starting at the fourth term would be taking our term here and going on this way. So the big difference is the fourth partial sum is going to be those first four terms versus the sum we just found, which is everything fourth term and on. Okay, so this last part, we are going to decide if the following series are geometric, and if they are geometric, does it converge? So it's not even asking if it converges to something specific, just does it converge or not. So is it geometric? So what we're looking for is a number to a power. So we have 1/2 to the power of n. This is a number to a power, so this is geometric. And it's r value, so the absolute value of r is equal to 1/2. Because it's 1/2 to the n, this is less than 1, so we know that it's less than 1, it converges. We have the summation from n equals 1 to infinity of 1 over n squared. This time we don't have the exponent in the power, it's just in the denominator, so this is not geometric. So for right now, we don't know what to do with this. We have the summation from n equals 1 to infinity of e to the negative n power. We're going to rewrite this really quick just to make sure. So we have the summation from n equals 1 to infinity of 1 over e to the n, which we can also write as 1 over e to the n power. This is in that form that we would normally see for a geometric. We have a number raised to a power. This is a geometric. And now we need to be careful because if I just look at what I have, e to the negative n, e is not our ratio. It's not that common ratio r. The absolute value of r is equal to 1 over e. Reminding ourselves that e is about 2.718. We're looking at something that is less than 1 again, so this converges. We have the summation from n equals 1 to infinity of 3 divided by 2 to the n power. I see a number to a power, but I'm going to rewrite this so it looks a little bit more familiar. So we have n equals 1 to infinity. 3 we're going to pull out front. That is not what I wrote. 3 we're going to pull out front. And then we have 1 over 2 to the n power. So this is just another way of doing to the 1/2, or 1/2 to the power of n. This is geometric. The absolute value of r is equal to 1/2. It's less than 1, so it converges. And our last one here, the summation from n equals 1 to infinity of 3/2 to the n power. This is a little bit different than what we had before. That parentheses telling us that the n is going to everything, so this would be 3 to the n divided by 2 to the n. So this is still geometric because we have a number to a power. The absolute value of r is equal to 3 over 2. 3 over 2 is bigger than 1, that's 1.5, so we know that this diverges. So if all we need to decide is if it's converging or diverging, geometric series and sequences are some of our easiest ones to kind of look at. They're kind of the ones that we hope they are, just because we're done with them at that point.